All right, this lesson is on the pH scale and pH calculations. So I want to just introduce you to pH. Perhaps you have a prior knowledge of acids and bases. Most of us have heard of battery acid and the acid in citrus fruits, things like that. Most of our cleaning supplies are bases. And so we're going to dive into what actually is acids and bases and how do we measure them. And so we have what's called a pH scale. And so when you think about the pH scale, most of us know that neutral pH is a pH of 7. It turns out that is true of pure water, as long as the pure water is at 25 degrees Celsius. The pH scale can go above 7 or it can go below 7. And notice there is an arrow on each end of this line, meaning that it doesn't stop at 0 and 14 as you may have thought. Actually, it can go below 0 and above 14. When you get a pH higher than 7, you are talking about a base, and when you have a pH lower than 7, then we refer to that as an acid. And so this symbol pH, whenever you see this lowercase p, p simply means the negative log. And so for pH, pH is the negative log of the hydrogen ion concentration. And so pH is a measure of the concentration of hydrogen ions. And so for acids have a very high concentration of hydrogen ions, a low concentration of hydroxide ions, and on the other end of the scale, bases have a high concentration of OH ions and a low concentration of H+. So hydrogen ions and hydroxide ions are related in this way. We can also have POH, and remember, P means negative log, in this case of the hydroxide ion concentration. So when we look at pH and POH, we can relate these two. pH plus POH is equal to 14 as long as the temperature is 25 degrees Celsius. And so that is a helpful calculation. And one other thing to make note of, if we know the hydrogen ion concentration, then that is equal to 10 raised to the negative pH. So if we know our pH and we want to find the hydrogen ion concentration, we can do this calculation. And then again, if we know the POH, we can take 10 raised to the negative POH, and that will give us our hydroxide ion concentration. So these are some important relationships that will help us do some calculations with pH and POH. So you'll see on this page that this square, this pH square, you see this a lot of times in textbooks as a tool to help you calculate between the various parts. And notice that we're always relating these four things: hydrogen ion concentration, pH, hydroxide ion concentration, or OH. That's what I have in the four corners here. And so there, shows you the path, changing one calculation to another. And so this might be helpful to write down and to keep handy to do your calculations. And then here we have a table. And so if you know any one of these four substances or values, you can calculate the other three quite easily, as a matter of fact. And so let's take a look at that, and I'll just kind of show you some shortcuts along the way. And so we have the table here, and the first piece of information that we're given in the first line is the hydrogen ion concentration. And if we can look at the table and see that if we have the hydrogen ion concentration and we want to find the pH, well, we simply take the negative log of the hydrogen ion concentration. So when we take the negative log of 1 times 10 to the negative 7, you will get the number 7. So let's look at something that may help you. So when you have 1 times, let me just write this. When you have 1 times 10 to the negative whole number, we'll just call that x. Well, then you want to treat this as being 10 raised to that negative x power. So because when you have a 1 here, 1 times anything is itself, so multiplying that 1 doesn't change the value of my number. So because of this fact, anytime we have 1 times 10 raised to the negative x, then a short way to make the calculation is if I take the negative log of 10 raised to the negative x, that's simply just going to equal x. So in other words, if I take the negative log of 10 raised to the negative 7, well, that's just going to give me 7. So be on the lookout for a simple calculation here. If you're given 1 times 10 to the negative whatever, then you don't even need a calculator to calculate that value. All right, back to our table. If we know the pH, well, we can easily go from the pH to the pOH, knowing that pH plus pOH equals 14. Now, you can always assume you're at 25 degrees Celsius unless told otherwise. And so here we see a pH of 7, so the pOH must be 7. Well, how do we get from pOH to OH? Remember, if I know the pOH and I want OH, I just take 10 raised to the negative pOH. So 10 raised to the negative pOH is 10 to the negative 7. We can write 1 times 10 to the negative 7. That's the same answer. So that was easy. We have our first row. All right, let's look at our second row. This time we're given pH. And so from pH to pOH, we simply take 14 minus 3, and that gives us 11. And then we can determine our hydrogen ion concentration and our hydroxide ion concentration. So this would just be 10 raised to the negative pH, so that's 10 raised to the negative 3 molar. And this will be 10 raised to the negative OH. And if we want, we can just put 1 times in front. All right, that's the second row. Let's look at our third row. This time we're given the OH concentration. And again, it starts with 1 times. So we can just take the negative log of 10 raised to the negative 10, and that's going to give us an answer of 10. 14 minus 10 gives us a pH of 4. And then we raise 10 to the negative 4 for our hydrogen ion concentration. Okay, and then next we have a pOH of 2. So 14 minus 2 is 12. The OH concentration would just be 10 to the negative 2. And the H plus would be 10 raised to the negative 12. I don't know if we did that quite easy. All right, so what if you don't have 1 times 10 to the something? So in the last example, we have 3.2 times 10 to the 8th. So just something to be aware of, as I increase the H plus concentration, the pH will decrease. I'll have a decrease in the pH. So if this was instead 1 times 10 to the minus 8, I know my pH would be 8. But since I've increased it to 3.2 times 10 to the 8th, then I know my pH is going to be less than 8. So it's going to be 7 point something. And so this is helpful if you're given a multiple choice question. You can do this simple math and maybe eliminate answers or possibly even pick out the correct answer. So I will take my calculator and I will find the negative log of 3.2 times 10 to the negative 8. And that gives me a pH of 7.49. 7.49. So let's take just a moment and talk about significant figures, sig figs, for logarithmic numbers. So there is a special rule for sig figs of logarithmic numbers, like pH and pOH and pKa and all of those P numbers. So anytime you have a logarithmic number, you only count the decimal places as significant figures. Only count the decimal places. So when we go to our example, on our last row up here, we had a concentration that contained 2 sig figs. And so that means our pH needs to have 2 sig figs to match. And so we had to have 0.49 to give us those 2 sig figs. All right, to continue to fill out our table, let's go to pOH. And so remember, we have to take 14 minus 7.49, and that gives us 6.51. 6.51. All right, if we know the pOH and we want to find the hydroxide ion concentration, so we're at pH and we want to find the hydroxide ion concentration. We take 10 raised to the negative pOH, 10 raised to the negative pOH, and that gives us 3.1 times 10 to the negative 7 molar. So this concentration is not a logarithmic number, so we're back to our old rules, if you will. And so 3.1 gives us the 2 sig figs. So we said that the kW value of 1 times 10 to the negative 14 is true at 25 degrees Celsius. We know that pH plus pOH equals 14 is true at 25 degrees Celsius. So what happens when we're not at 25 degrees Celsius? And so we can take a look at what implications that has. So let's scroll on down and let's just say so if the kW equals 1 times 10 to the negative 13 at 37 degrees Celsius, what neutral water. So what would be the pH of pure water at 37 degrees Celsius? Okay, so we can use our same concepts that we've learned to figure this out. So we know that according to the little table here, we know that H plus ions plus OH minus ions is equal to Kw. And so that is still true no matter what the temperature. H plus, OH minus. It's just that this case that our Kw is slightly different. So 1.0 times 10 to the negative 13 is equal to H plus and OH minus. So if we call these values for H plus and OH minus X, then we can solve for the value of X. So X times X, which is simply X squared, let me fix this, negative 13. So to find out X, we would simply take the square root of both sides. And we will discover that X is equal to 3.2 times 10 to the negative 7 molar. And what is X? Remember, X is H plus and it's OH minus. So that's our concentration. And notice they're equal, the same. And so what would our pH be then? So if we wanted pH, we would have to take the negative log of 3.2 times 10 to the minus 7. And remember, we should get, since this is not a 1, it's 3.2 times 10 to the negative 7th. That's going to lower our pH. So instead of pH being 7, the pH is going to be slightly lower. So we know it's going to be 6. And we need those two decimal places to have our two sig figs. So we can do the math and find out it's actually 6.49. And this would also be equal to our pOH. 6.49. So it does change the pH slightly when the temperature is raised.